Alright, ladies and gentlemen, as promised, here is the short video lesson on section 11.3 in your textbook. That's Graphing with Intercepts. It's on page 444. So if you'll remember from class this week, we talked about the fact that the equation of a line, the table of values, and the graph are all interconnected and related to one another. And if you have one of those things, typically you can find the other two if you need to. And so in class on Wednesday, we talked about if we had an equation, we could then create one of those t-charts like this with some values. I said use -2, -1, 0, 1, and 2 as kind of a default, but you can use whatever values you'd like. Plug those values into the equation and find your y's, and then you can plot those things, and you'll have a picture of the line that accompanies that equation or goes with that equation. So if you'll flip your book over to page 444, I'll wait. Pause the video if you need to. And go ahead and actually flip to page 445, because that's the one we're going to look at. Basically, if you look at those four graphs on page 445, so just focus on those graphs for now. Look at the very first one. You'll see a line. Below it, you'll see its equation, 2x plus y equals 6. And you'll notice that, first of all, you'll notice that in the equation, you've got the x and the y both on the same side. That's kind of important. We'll talk about that again in a minute. But if you look at the picture, you'll see that they've highlighted 2 points. And the points that they've highlighted are the 2 points where that line crosses the x and the y-axis. So you'll see it crosses at 3, 0 on the x-axis, and it crosses at 0, 6 on the y-axis. So those 2 points where that line crosses are called intercepts. And of course, the point where it crosses the x-axis, in that first example, that's 3, 0. We call that the x-intercept. And of course, the place where it crosses the y-axis, you guessed it, we call that the y-intercept. And so we have this equation, 2x plus y equals 6. And if we didn't have the picture and we didn't see where that line crossed the x and y axes, that may be some important information to find, because I think we probably have all heard that old saying, the shortest distance between 2 points is a straight line. Well, that kind of holds true here, in that if you have 2 points on a line, you can connect them with a straight line, and you'll have a picture of the line. So theoretically, and what you're going to see in this section, if you have those 2 points, those x and y intercepts, then you can graph the line. You don't actually have to have all of the points that we had in our charts on Wednesday. So I won't say that this method is going to replace that method. This method is going to accompany that method, because there's times when this method is easier to use, what we'll call the intercept method for graphing, and then other times the t-chart or the table method is easier. And really all that depends on how this equation is presented to us. Okay, so just kind of keep that in your mind. We'll continue to talk about it as we go. I've got to be careful here and keep this kind of brief, because I don't want to keep you a long time. I want you to have time to work on your quiz and your homework and that sort of thing. So I'm going to jump on down to the examples. So example 4.19, which technically starts on page 446, but the work starts on 447. You'll see that it says to find the x and y intercepts on each one of these graphs. So if you look at 447, we've got 3 graphs there. And the first one, graph A, and I'll draw a quick little sketch of it just so I can kind of talk about it and point out some things. So it sort of looks like this. My graph is not perfect, but you'll see that the point right here is 2, and the point down here where it crosses is 4. So those are the only 2 points we're really concerned with, are the 2 places where that graph crosses the x and y axis. So remember, this is the x-axis, that's the y-axis. So if I asked you for the x-intercept and the y-intercept, what would you say those are? Now remember, when we identify points, we identify them with coordinates, an x-coordinate and a y-coordinate for each one. So x-intercept, what do you think? Go on, say it out loud. If your roommate's in there, just look at him funny and say it out loud. That's right, it's 4, 0, 4, 0, because that's this point right here, 4, 0. And then the y-intercept, go on, say it too. That's right, it's 0, 2, 0, 2. So that's this point up here, right there. That one is 0, 2. So far we've learned that the x and y intercepts are the two places where the line crosses the x and y axis, and when we identify those, we identify them with coordinates. Okay, so if we have a picture of the line and we're asked to find the intercepts, we simply just look for the places where it crosses the x and y axis. Now, if we have an equation of a line, like in example 4.20 on page 448, things are a little bit different now. We don't have that picture to look at, and we could graph it. We could make a t-chart, find some values, draw a picture, look for the places where the line crosses, and that'll work. But there's a much easier way, a much simpler way to do that. And so we talked about in class, and we've worked on before, kind of filling in these charts, right? Well, we also have looked at today, we've looked at the idea that the y-intercept is the place where the x value is 0, and the x-intercept is the place where the y value is 0. So theoretically, if I can fill in those two blanks, I should be able to find the x and y intercepts just with the equation. So this is just a substitution exercise. So if I plug in into 2x plus y equals 6, so if I put x is 0, so if I take this 0 and plug it in for x, and I solve for y, well, that isn't too hard because 2 times 0 is 0, so that means y equals 6. That's all that's left. Then there's my y-intercept, 0, 6. If I then go back and take this 0 and plug it in for x, or rather, sorry, for y, so I've got 2x plus, and then instead of y, I'm going to put in 0 equals 6. Then that just means 2x equals 6. I can solve that by division, and x equals 3. So with a little bit of substitution and just a touch of algebra, not too much, we can find those two intercepts. The y-intercept is 0, 6, and the x-intercept is 3, 0. And I think arguably that is an easier way, an easier method, as opposed to finding values and drawing a picture and then looking for the intercepts. Okay, so one more example here, and that's to graph this equation, or the line that goes to this equation, using the intercepts. Notice it says using the intercepts. So the first thing I'm going to caution you of is there's more ways to graph y equals 5x other than using the intercepts. We can use the table method. We're going to talk later about another way to do it. So what I want you to focus on in this chapter altogether is to focus on using the method that we're using at the time. So if it says use the intercepts, okay? So to find the two intercepts, we'll do what we did in the last example. We'll put in some zeros. And you're going to see that this one's even easier just because of the equation itself. So if I put in 0 for x, that's going to look like this. Y equals 5 times 0. And we'll see quickly that y equals 0. Okay. So wait a minute. If I put x in as 0, I get 0 for y. So if I put 0 in for y, won't I just get 0 for x? I believe so. So what does that tell me? That tells me that if I sketch out a little graph down here, that tells me that the x-intercept is right there. Well, so is the y-intercept. Well, that makes sense. It's the origin. It's the place where the x and y-axis cross. So if I draw a line through that, it's going to go through the x and y-axis at one point, not the x-axis at one place and the y-axis at another. So, okay, I don't have a picture of the line yet. I don't have another point to attach this to. So what I'm going to have to do is just create another one. Okay, So I'm going to find another point. Let's make it really easy on ourselves and just put 1 in for x, which means y equals 5 times 1, or 5. So I found another point, 1, 5. I'm going to go to 1, 5. 1, 2, 3, 4, 5. And, I mean, this is in no way accurate. Don't kid yourself, but it's okay. And then I can sketch now a picture, and you'll see the picture of my line. It's never going to cross the x or y axis at any other place, right? It's only going to cross in that origin. So occasionally you'll come up with problems like this where your x and y axis, or excuse me, your x and y intercepts are both the origin. And when that's the case, you just have to find another point on the line. Your book's going to tell you to find 2 more points, and you can do that, but I'm going to say just 1 more is plenty. And that way you can then graph. That's going to do it, guys. That's all I've got for you. Keep in mind the homework assignment is still the same. It's still what's on Canvas. That's not changing. The only thing that's changing is I'm adding, instead of going to class at 10 a.m. On Friday, you're going to watch this video, hopefully to completion. I hope you've made it this far. Otherwise, you won't hear this, and it doesn't matter anyway. But then also, there's going to be a little quiz posted on Canvas right under this video. Probably a link to it right under this video. Just go ahead and complete that quiz, and you should be good to go. We're going to have another quiz on Monday over 4.1, 4.2, and 4.3. The quiz below is just over the stuff that I just talked to you about, so it's just going to be over 4.3. And I'm calling it a quiz because I can't think of anything better to call it. It's really more of your, quote, classwork assignment. So it will count as those points that you normally get for coming to class and doing work in class. So I'm going to shut up now because I've rambled on long enough. Thank you so much. Hopefully we'll be celebrating a victory today for the Bears. Hopefully it'll be our second victory that we'll be celebrating because our women play, depending on when you watch this, Thursday at noon. So hopefully we'll be celebrating 2 victories. Have a good day. Go Bears. I'll see you on Monday.